What up, squad? Mr. Hur here. Sorry I couldn't be here this Friday, but you guys already know that I was headed off to Kalahari with the kiddos, so they're going to be having a good time. But I'll try to keep this light and easy for you. We're on page 63 in your notes, so please follow along. We're going to grip it and rip it, right? All right. The side postulate, notice that's abbreviated SSS. What that says is if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. No surprises there. If the sides are exactly the same the whole way around, guess what? The triangles are exactly the same the whole way around. Notice GH has a single tick mark, PQ has a single tick mark. So those are the sides that correspond. You get the idea. You have total freedom when naming the first one. What I mean by that is this first triangle right here, go any order you want. I'm going to go G, H, F. But then you're locked in. What I mean by that is from G to H to F, well, from G to H was a single tick, H to F was a double tick. So that means I have to lock in the exact same way over here. So I have to go with PQR. Why? Because not only do the sides match up, GH, PQ, HF, QR, but it also lets us know the angles match up too, which we're going to talk about here momentarily. Another way to show triangles are congruent is side angle side. Basically, it says if two sides and the included angle, that means what's in between the congruent sides. See how C here is between a congruent CB and CA? Anyhow, if those are congruent, then the triangles are congruent. And same idea when it comes to naming, you have to be consistent. You have total freedom with this first one. So being totally unoriginal, I'm going to call it ABC. But notice, from A to B, no tick mark. B to C, single tick mark, and C is the congruent angle. So when I'm over here, I have to name this one EFD. You have to be consistent because then we know what everything matches up and it's good to go, right? You're going to see a lot of proofs in this. I don't expect you to be experts on this, especially because I'm not here and you're watching a video, but we have to bust this stuff up. Welcome to how we do every proof in this course, right? We start with the given statement. Here we have some new things, but some stuff that'll make sense. M is the midpoint of XY, is what we're told. And we're also told AX is congruent to AY. Okay, so I personally am going to come over here, put a tick mark on AX, tick mark on AY. Why? Because we know that to be true. We were given it. All right, then here is a new term. Again, don't panic. I don't expect you to have it perfect, but both of these triangles, AXM and AYM, don't they share this AM? Isn't it congruent to itself? Well, we're going to have a term this unit called reflexive. Reflexive is when something is congruent to itself. It's like looking in the mirror. That's how I think of this when we say reflexive. It's like reflection. You're congruent to your reflection. So AX and AY are congruent. We were given that, but AM is congruent to itself. So right now we have congruent sides here, and then believe it or not, a shared congruent side there. If we could just prove these, we'd be good to go. We actually can. Because we were told M is the midpoint. Well, remember, midpoint, split something in half. So that means XM must be congruent to YM because of the definition of a midpoint. This is the first time we've seen a definition in our proofs. So don't panic, but you just think about what a midpoint does. It splits something in half. So it must be true. Now look at what we have. We have side, side, side. Ooh, so these triangles must be congruent. Specifically, triangle AMX must be congruent to triangle AMY. Sorry about the shaky stand, but you guys are probably used to that by now. I never even notice it most of the time. Let's flip this thing. Don't worry, as far as I remember, that's the only proof for today. Here on page 64, it says about using side angle side. What other information do you need to prove that triangle ADC is congruent to triangle BCD? Okay. Well, if we're going to use side angle side, can't we agree that these triangles ADC and BDC, don't they share DC? Of course they do. Well, if that was the case, we would need to know, in order to use side angle side, we need an angle. Specifically, we would need, sorry for the bad we need that angle ADC with, notice, D is the vertex, must be congruent to angle BCD. If we're going to use side angle side, that's a must. Okay. Here in 3, sort of building into a proof. Don't worry, it's not a proof. This says angle RSG, so follow it with your pencil. RSG. Ooh, so right here is congruent to RSH. We're also told SG is congruent to SH. From the information given, can you prove that these are congruent? Triangle RSG and triangle RSH. Explain. We can, because RS is congruent to itself. Do you see how RS is shared by both of these? And then we have side angle side, side angle side. Ooh, and that, folks, again, it's not a proof, don't panic, but this is the reflexive property whenever something's congruent to itself. Okay. In this, for the sake of the video, this is exactly like what we did on 64. We're given that HF is congruent to HJ. We're told these are congruent FG and JK. And then we're told H is a midpoint. Well, by the definition of a midpoint, if I was going to run through this proof, we would show that that splits that in half, and then it's side, side, side for the win. But I'm not there. I know this video is getting long, so I'll try to hook you up the best I can. I guess we'll knock out these two, and then you can grip it and rip it on your homework. What other info do you need to prove ABC is congruent to CDA by SAS? Okay, we would need to know that this angle here between the 7 and the 6 is congruent to this angle here between the 7 and the 6. Specifically, angle DCA is congruent to angle BAC. That's what we need. Okay. Last but not least, EB is congruent to CB. We have this over here. And AE is congruent to DB. We have that over here. We have vertical angles here, but this is a really tricky problem. I hope this plays well over the video, because vertical angles, we know they must be congruent, but they're in the wrong spot. We would need an angle here at E and an angle there at B. Well, we have the one here at B. We don't have it right here. So can we prove that these are congruent? Explain. We can't, because we need angle E, because it's included between our two sides, but we don't have it. Okay. Hey, I don't expect this to be easy. I know it's tricky when I'm not around, so I do apologize. So those are our notes. When you're ready, give this thing a flip over to 65. Okay. I would like you to try this. You know, keeping it real, the last two are proofs, but they're simple, really simple. In fact, I think each of them are only 3 steps. So it's given, a reason in the middle, and then a proof statement. But really, what I'm concerned about is what's here up top. It says, determine whether we can use side, 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 or side angle. If so, write the congruency statement. If not, write not possible. Okay. I'll do one with you just so we're clear of expectations. In fact, number 1 is going to work. I'm going to tell you flat out it's going to work. BA is congruent to BC. We also have angle ABD and angle CBD are congruent. Notice they share BD, so that's reflexive. So this is yes, SAS, so we say Y, and now we have to name it. And again, I'm just trying to drive home this naming. Name the left side however you want. I'm feeling kind of bad right now, so I'm going to name it BAD. BAD. Must be congruent. Now we have to stay consistent. B to A was a single tick, so B to C, and then we'll go to D. This is congruent to B, C, D. The B's matches up, the A matches up with the C, and the D's match up. Okay, so you have to be consistent with naming. Hey, in the folder, you also find the keys to this. You also find pictures of the notes. If it was too shaky, I do apologize. Appreciate all your attention, and you have a great Friday. Enjoy your long weekend, kids. We'll see you on Tuesday.